Hello, hello. Great to see you and welcome to today's lesson. Today's lesson is a continuation of what it means to use elimination. Today just takes it a step further. So let me just quickly remind us here that elimination we would use, if you were in class, we would be doing this. We use elimination when we see two things that eliminate. So here our -4 and our +4 would cross off because -4 plus 4 equals 0. And we would get 10x equals 21, and we could solve for what x is. So elimination we use when we have a variable that will eliminate when we add them together. Same thing happens with this one. This one I asked you to do in class if you were present. If we add these two equations together, we could see that the 4x and the -4x would go away because, again, 4 and -4, they're equal but opposite. And then we get -7y equals -35. Now, and then again, the point of doing that was because now I can divide both sides by 7, by -7, or I can ask myself, -7 times what value is going to give me this -35? And that answer would be y equals 5. The biggest thing I want us to realize, though, and remind ourselves, is that it's by adding these equations together, we had something that we could cross off. Sometimes that isn't the case, though. If I gave you this problem, what happens when we add these two together? Does anything eliminate? The answer is no. If we look at this one closely and we try adding these together, well, 3x and 2x is 5x. 2y plus 2y is going to give us 4y, and then 20 and 17 is 37. Nothing eliminates for this one. That's because it's not that rule of being equal and opposite. Remember, to make them cross off and equal 0, they need to be the same number but also opposite, because +2 and then a -2 would then give us a big 0, and we could cross them off. But because these two are both +2, if you add them together, 2 plus 2 is 4. So that is an issue. Sometimes we aren't given equations that are set up perfectly for us. And so we find ways to make them be the way we need them to be. So this is another way that systems can be like puzzles. It's all about problem solving and trying to figure out ways to maneuver and change the equations to make them be set up how we need them to be. So with that being said, we'll go ahead. I'll open up my OneNote now so you can fill this out with me. So what we're going to look at is, well, what can we do when this happens? How can I still use elimination if things don't eliminate? Well, like I said, we can change it. We can make it so things that eliminate. It's just on us to do it. So if we have this problem here, let me move my little thing over slightly. Alright, sorry, got a phone call. Okay, so today with the rest of this lesson, it's all about what we can do to make it so that we can use elimination. Our next lesson will be combining this with actually solving the system, but kind of like we've done when I've introduced elimination and substitution, where we did one small thing at a time. That's what we're going to do today. So just like one small bite-sized thing, and then we'll do a whole elimination problem on Thursday. Okay, so how can we make this the way we need it to be? So what we can do is we can multiply the equation, one of the equations, by a number to make one of my variables eliminate. And I'm going to show you how that works. But some questions we can ask ourselves for this are what would be easier to make equal opposites, the x's or the y's. So if we look at this first one here, to make an x, well, if you look at your x's, we have an x and then a 2x. So for my x's to cancel, this would need to be a -2. For my y's to cancel, this is a 3 right now, so this would need to be a -3. So none of these really end up being harder than the other. So I could choose the x or the y. And then, do I need to multiply the bottom or the top equation? For this one, we would want to multiply the top. it's easier to turn a 1 into a negative 2 or a 1 into a negative 3 versus take the 3 and turn it back into a 1. So you usually want to choose the smaller and then make it larger. And then what number do I need to multiply it by to make that variable eliminate? So like I said, this one, you can't really choose a wrong one. So again, that's the thing with these problems is they have a lot of different ways you can solve it, and you can still get it right even if you do it differently from me. So for this example, let's say I choose the x's here. I want to make the x's eliminate. Right now, this is a 2x. Remember, to cancel out a 2, I need a negative 2. They need to be equal and opposite. So I need to multiply this top equation by a number to make this x become a negative 2. Well, right now there's a 1 in front of it, so to make a 1 become a negative 2, oh my goodness, this pen is not working. So we're going to take 1 times something to get negative 2, and that number is just negative 2. So I'm going to multiply this whole equation by negative 2. 1, 2, and then we're going to use the distributive property, and we're going to multiply it through the whole thing. So with equations, there's this property where you can do anything as long as you do it to the entire equation to keep things equal. So negative 2 times x is negative 2x. Negative 2 times y is negative 2y. And then we have equals 12. And then I'm going to just rewrite that bottom equation. And that is all we're working on. Now you can see when we look at our system here, now our x's would eliminate. We have a negative 2x and a positive 2x. So the practice today, there's like 8 problems where I just want you to try picking the number you need to multiply by. If one of your variables ends up not eliminating, like if you look at this and you don't have anything that would cancel out, you did something wrong. So let's try another one. So now we're here. 3x plus 6y equals 6. 9x minus 12y equals 18. So again, 3 and 9, those don't cancel. 6 and negative 12, those don't cancel. Okay. Again, is anything easier to make eliminate? Like, is it hard to make a 3 become a negative 9? No. Is it hard to make a 6 become a 12? No. So again, this one you could choose either. And I can show you that too. I'll show you that next. So let's say we choose the x's here again. So let's say we want to cancel out those x's. So that tells me I'm going to make my 3 become the opposite of a positive 9, which is a negative 9. So again, I need this x to become a negative 9x, so they eliminate. So 3 times what gives me negative 9? Three times negative 3. Oh my goodness, I can't write over there. So 3 times negative 3 would give me that negative 9 that I need to eliminate. So I'm going to multiply this whole equation by negative 3. Negative 3 times 3x is negative 9x. Negative 3 times 6y is negative 18y. And negative 3 times 6 is negative 18. And then again, I'm going to rewrite the equation that I didn't touch, so that bottom equation in this case. Great. Again, now we can see these 9's right here would eliminate. We have a negative 9 and a positive 9. Therefore, I did this right, and now we would be able to use elimination. Okay, last one. So we have 4x minus 2y equals 20, negative 8x minus 3y equals 16. So again, are one of these variables easier to make eliminate than the other? Well, let's think. So is it pretty easy to make a 4 become an 8 with multiplication? Yeah. Is it pretty easy to make a 2 become a 3? No. If you think of 2, we can do 2 times 1 is 2. 2 times 2 is 4. So you already, like, 3 is not a multiple of 2. You'd have to multiply the 2 by some sort of fraction to make it equal 3. So for this one, you would want to choose the x because it's really hard to make a 2 become a 3. So we have 4 and then a negative 8. So I'm going to multiply this top one by something. So we're making the x's eliminate. This is a negative 8. So if this is a negative 8, the opposite of that would be a positive 8. So I need this 4x to become an 8x. So 4 times what gives me 8? 4 times 2. So that's what I'm going to multiply by. 2 times 4x is 8x. 2 times negative 2 is negative 4y. And then 2 times 20 equals 40. And then again, rewrite that bottom equation. Negative 8x, negative 3y equals 16. And then again, we have an 8x, we have a negative 8x. Those would eliminate. So I know we did this correctly, and we would be able to solve this with elimination now. So sometimes it's going to be the bottom equation that you multiply. I think I show you that. I think we have some like that down here. Okay, so like this one, number 3 in your IP. Okay, looking at this, again, it's pretty easy to make a 1 become a 4, or pretty easy to make a negative 3 become a negative 9. Multiply by 4, multiply by 3. So there isn't a wrong choice here, but in this case, it would be the bottom one that you would multiply. Again, it's easier to make the smaller number become a larger number. So this is the one you would multiply by. You would rewrite the top equation down here, and then the new one below it. Okay, I know this can be a little confusing, so if you need to rewatch me and try again and like listen to these again, do it. I did make another example for you down here, and then I've helped you I've helped it kind of get started a little bit in these first few in your IP, and then same for this one. If you need to stop, like I want you to make it through 9 through 11. If you can't do 12 and 13, that's okay. That is what the next lesson is for. So if you need to stop here at 11, you could do that, but I do want you to make it through 11. The only difference with these 3 down here is that after you do the multiplication, I then want you to add them and watch that thing eliminate. Watch that specific variable eliminate. Okay, give it a shot. Again, if you need help, let me know. One more time. So we have a 7x plus 2y equals 24, 8x plus 2y equals 30. It's hard. We want to make something eliminate. So we need to multiply an equation by a number so that way we get a variable that eliminates. 7 is my smaller x value. That's hard to turn a 7 into an 8 with multiplication. 2, I have a 2y and a positive 2y. So the only thing here is I need to make one of these 2's negative. So what could I multiply 2 by to make it a negative 2? Whatever that number is the number that goes here. So again, the opposite of a positive 2 is a negative 2. So you need to say, well, what can I multiply 2 by to get the negative 2 that I need? All right. Again, try this. See how you do. If you need help, let me know and I can help you. I really want you to try your best on this. All right. Great. Hopefully I hear from you soon.